We started this working group back in fall of 2019, and so we're now on to our fourth year. We went on to our fourth year because of COVID difficulties and also difficulties in scheduling our in-person community workshop, which we actually did this year, which I will talk about briefly. So today's update, I'm just going to give you a review of our working group goals that we'd set in our initial prospectus back in 2019. And just give you an update on what our accomplishments have been during the past year. So we've been pretty busy with working group activities, and so we'd like to share those with you. And then finally, we're going to try to finish up this fall, and we're going to just give the final goals of our working group and what we hope to finish up and accomplish there. So just to give you just the broadest level introduction to what our working group was trying to address. So this mesoscale air-sea coupling that we prioritize or focus on in this working group relates to a lot of aspects of the core CLIVAR research objectives. And that goes from subseasonal to seasonal prediction and Earth system predictability, decadal variability and predictability in the Earth's climate system, climate change, climate and extreme weather events, polar climate changes, climate and marine carbon and biogeochemistry, and ecology as well, and then climate along the coast. And I should also mention that there are a number of different aspects that aren't necessarily identified explicitly in these, and this includes impacts of air-sea coupling on the Earth's hydrological cycle, so things like distribution of precipitation and aspects of terrestrial drought, marine heat waves, both in the coast and the open ocean, and ocean ecology, so things like species proliferation and distribution, fisheries, and things like that. So this working group really it's very interdisciplinary, and it touches on a lot of different aspects of Earth's climate system. So our initial working group objectives were just to formulate and coordinate observational and modeling efforts to quantify the influence of the oceanic mesoscale and frontal scale air-sea coupled processes on Earth's climate and hydrological cycle. And so last year, we finished our review paper, and it was published in the Journal of Climate. And this review paper synthesized our current understanding of the air-sea coupling and impacts on Earth's climate, and also raised a number of open questions that, from a consensus of the community. And there were a number of them, and I will further down, I will go into a little bit more detail on those. But it basically provided a place where we could show where the science is, and we can use that to help formulate a path forward for better observing and modeling these systems and to better understand them. So that was one of our goals, and we've checked that off the list. So we've also wanted to develop diagnostic framework and analyze models and observations using a set of robust metrics. So we address this basically when you get data and you have all these science questions to answer them with. We need to be able to analyze the data and make sense of that. How to take these how to best look at the impacts of air-sea coupling on weather systems, on Earth's climate, and things like that. And to be able to do that in the constraints of what model output we can get and what observable variables we can get. And between our review paper and the community workshop that we held this past March, we have been able to actually develop some of these frameworks that seem to have a consensus within the community. So I'm going to check that off. And then finally, and probably one of the most important parts, is to take all this information that we've gleaned from both our working group members and then also from our workshop, and also with our associated activities and other efforts that have a lot of overlap with our working group goals. And that was to identify a consensus on uncertainties and directions forward for observing and modeling air-sea coupled processes on the ocean mesoscale specifically. And the goal of that was to guide in situ and satellite observations for optimum sampling strategies, and also to really identify the key variables we need to best observe air sea coupled processes and to improve modeling, predictability, and understanding of all the other parts of the Earth system that depend on accurate knowledge of air sea coupling. And we want to motivate coordinated process-oriented modeling and observational studies and diagnostic studies, and then broker community efforts following on to other previous CLIVAR workshops on related topics. And so in the review paper and in some of our other activities with the workshop, I think we've also done that as well. So I think we've mostly met our key objectives in our working group so far. Whoops. So the workshop we held was in Boulder on March 6th through 8th in 2023. And so this was a community workshop. And it was the goal of the workshop really was to get community input on this topic, both on the state of the science and then on various paths forward and how to best improve our observations and modeling capabilities. And I think just from the feedback we've gotten, the workshop was really successful. We also wanted to gather together researchers from various stages of careers, from different disciplines, so it's very interdisciplinary. People who wouldn't usually talk, necessarily work together, but who work on various aspects of air sea coupling. That was the focus here. And from that, it was really quite successful, and we were quite pleased with how that went. So the workshop objectives were to basically engage the research and operational communities to solicit feedback on the state of the science, to identify key gaps in understanding of air sea coupling and the spatial scales on which it occurs, and to provide recommendations for pathways forward to improve observational modeling capabilities of specifically around air sea coupling. And there's probably a fourth goal here that, after going through the workshop and as we're writing the workshop report, was to also and try to address the question about, if we keep the observing and modeling systems along the status quo, so keep doing just what we've been doing and don't improve them, what is it about what processes, what impacts on Earth's climate system will we miss out on? And I think that was a really important question to be able to justify continued improvements along these areas. So session themes that we had for the workshop were, so we had 6 different sessions, and we had invited speakers for each one, and then we had some discussion sessions associated with each of these that were focused on each of these sessions. So we looked at the boundary layer, atmospheric and oceanic boundary layer, and the surface heat, momentum, and gas flux responses to mesoscale ocean variability. Session 2 looked at the free tropospheric and extratropical atmospheric circulation responses. So basically, how does western boundary currents, how do eddies in the ocean, how do all these filaments in eastern boundary currents, how do those actually influence the weather on synoptic timescales? And then how does this also affect longer timescale circulation responses? So for instance, the ENSO, the Pacific Decadal Oscillation, and things like that. The third session looked at the feedback of these atmospheric responses onto the ocean. So the air sea coupling we're looking at is a fully coupled system with lots of feedbacks between what the atmosphere responds to in the ocean and then what the ocean responds to in the atmosphere. And so we wanted to look at how those, if there are positive or negative feedbacks, and what were the important processes that we need to capture to really look at that. The fourth session looked at the current state of modeling capabilities, and these models ran the whole gamut of our Earth system prediction models, from synoptic weather models to on kind of the short end, to climate models on the long end, coarse resolution climate models. And most of these were looking at coupled ocean atmosphere models, since those are been identified as really a key feature that's needed to accurately model the air sea coupling that we're looking at. The fifth session was looking at the state of our observational capabilities, and so this is both the in situ and satellite observations. So what the current state of it is, and then what variables do we really could really benefit from, could really benefit the science and our modeling capabilities what variables do we need, and then what is feasible in the next 10 years or so. And session 6 looked at future strategies for both observations and models. So looking at taking where we're at now with the current state, and what is it that the science is telling us that we need to do to improve this, and what kind of things can we expect, what improvements can we expect from these future improvements in both the observational modeling systems. And so our desired outcomes really to incorporate, we really sought out community feedback. So the working group has worked on this for a long time, and we have expertise in these areas, but we really wanted to see what the community thought of, and especially getting various disciplines together and looking at really what different communities that have overlapping interests in the air-sea coupling that we're looking at. What did they think about the current state of the science and where we need to going forward? And so all this feedback was collated together, and we're right now working on a workshop synthesis report. And we'd like to possibly also do a workshop paper, for instance, in the Bulletin of the American Meteorological Society, so that we could let the broader community know where the challenges in air-sea coupling lie right here. And this workshop synthesis report, we definitely will plan to give that to the Science Steering Committee and agency program managers, so that we can try to get this information into the hands of decision makers and other stakeholders as well. And the last outcome, which we thought was actually quite important, was just to bring the researchers and practitioners from all these different fields and disciplines, make new friends, and kind of blind each other with science. So, and we heard a lot of feedback about that. People really saw things from a very different perspective, and so there was a very positive experience, and we really thought we did a very good job with that there. And the participant diversity in the workshop, this is, I think, a pretty important component of the CLIVAR working groups, is to increase participation, both for all members of the community and for both domestic and international participants. So at the career stage of the participants, we had a lot of early career and students. So more than half of our participants were either early career or student participants, which we were delighted for. The gender breakdown, we were still about 60% male to 34% female. So a little bit improvement, but still more to be done. And finally, we had scientists from 15 different countries, nations. So we had 70% participation from the US, and then about 30% participation from international participants. So we're really quite proud of that as well. So going back to our working group activities, our core working group activities, within the last year, we have the review paper that has been published in the journal Climate. We tend to try to hold bi-monthly research seminars to the working group. And these are composed of researchers either as members of the working group, or we invite members from the general research community that have, that we thought would be interested to hear from. We've assisted in planning US CLIVAR Gulf Stream workshop that was held June 2022 at Woods Hole. And we held our community workshop in Boulder, Colorado during March of 2023. And one other activity that we had, I didn't put on here, is that we had a CLIVAR sponsored session at the AGU fall meeting, which many of you may have seen, that was actually very well attended. And yeah, and so it kind of, furthered participation and, into the field of air-sea coupling here. And just our recent bi-monthly seminar series, we've had several participants, both inside and outside our working group. And these are just some of the topics that we talked about. And usually these science seminars usually go for about half an hour, and then we have about a half an hour or so of discussion between the working group members and the speaker, which is always very enlightening as well. And this is our review paper in the journal Climate, and this was really a really big effort. We knew it was going to be hard, but it towards the end it was really difficult to get information in kind of a summary fashion, that wasn't that was, you know, somewhat technical, but not too technical. And then also making sure that we kind of bring together as much about the current research as we could together. And I just want to call out Hyodae Seo for really leading this effort. He really spent a lot of time doing this, as we all did, but he really led this effort and brought it to the end. So if you'd like to take a look at it, I mean, there's a QR code here. And we also publish this open access, so it's available to all members of the community, both international and domestic, which we thought was a very important part of what we could do as the CLIVAR working group. And so this review paper, like I said, it reviewed recent advances in many aspects of the role of air-sea coupling on Earth's large-scale climate. And we really thought that this was a unique perspective that was provided beyond past review papers, in that, you know, past review papers and past studies have kind of looked at various elements, technical elements of air-sea coupling. For instance, you know, the just the physics of the coupling, the dynamics, some of the responses of the climate system or whatever. This review paper also went into that, but we also made sure to focus a lot on the impacts of this coupling on the large-scale climate, and really looking at the studies and trying to find out what the current state of knowledge was for how mesoscale air-sea coupling impacted Earth's climate. So it kind of tried to address, at least partly, why should we care? And I just put together a brief list of both our review paper and our community workshop key synthesis points. And these are the things that we tried to make in the review paper. And then we'll also try to make that in our workshop report and BAM's article when we get out. And probably the first one is that air-sea interactions, especially on the ocean mesoscale, is a crucial and underappreciated component of Earth's climate system. And it includes elements of the ocean, of the hydrological cycle, ocean biogeochemical cycles, and climate change. Really keyed in on the importance of sustained global observations of air-sea interactions from in situ and remote sensing platforms. And these lack of measurements really hampers our ability to learn more of the air-sea coupling and how it impacts the climate, but also it really hampers our ability to predict on either from weather timescales to climate timescales, variability in Earth's climate. And a key point also is we'd like to capitalize on recent advances in sensor and platform technology to improve surface heat, momentum, and gas flux observations. So there are very few in situ observations. There are little to no satellite observations. And so we're really in the blind of one of the key components of how two of our main components of the Earth's climate system interact with each other. And there's also pointing out that emerging in the evidence is really indicating that surface current measurements are a critical missing piece of our current flux observing system, and it's really something that will be needed going forward. And the oceanic submesoscale is being recognized as important and missing element of air-sea coupling and large-scale climate. And what we mean by the ocean mesoscale is basically ocean variability in the ocean on length scales under 1 to 10 kilometers. And so that really tests the resolution limitations of both our satellite observations, our numerical weather models, our coupled climate models, and also our in situ observing system. So we are just not really capturing these dynamics, and there's emerging evidence that what's going on at the ocean submesoscale is an important piece of air-sea, of how the ocean atmosphere interact. And you know, if we have to go down to ever smaller spatial scales than what we can measure now, this will drive more stringent requirements for spatial and temporal resolution in our next generation observation and modeling systems. And finally, you know, an important part of this too is that there's you know, a fair amount of diversity in how we diagnose air-sea coupling in both models and observations. And an important part of our working group was trying to find a common framework in which to look at and understand key physical processes in air sea coupling, and to also know how, if we're observing or modeling these interactions correctly. And a key, kind of a common theme in this is that these diagnostics all require long observational data records and a sustained commitments to both observational and modeling systems. So we need for modeling systems, we need lots of disk space and archives. And for observational system, we need long, uninterrupted, and accurate observational data records. And many of our members are participating in a lot of different activities that are able to take this information, take these new things that we're learning, and kind of bring this to the community and put this into into effect a lot. And I just put a bunch of different programs and experiments and projects that people in our working group are involved in and currently. And so this is really kind of giving some broader reach to our working group activities, and also some interactions between other groups that benefit both our working group and also benefit the work of these other efforts as well. And our final activities that we're planning to complete by the fall of 2023 is to, first we need to complete our community workshop reports. We plan to do that by August. We'll continue our bi-monthly webinars and working group meetings. A couple of us are in the organizing committee and participating in an international air-sea coupling workshop that's going to be held in September 2023 in the Netherlands. And NASA is providing some US travel support for that, so we thank you for that. And we're organizing an air-sea interaction session at the 2024 Ocean Sciences meeting in February. And we're still working on developing plans for a data repository and a framework for diagnostic metrics to assess air-sea coupling and observations and models. And this is important because even people within the air-sea interaction community are often not aware or don't know or don't have access to different modeling data outputs or different observational outputs, or aren't aware of their existence. And so this was an effort to try to kind of bring more awareness to both the observational and modeling community of what's out there, And so that's all I had. And and I'm happy to take more questions. One discussion question that we had as a working group, and we've talked about this quite a bit, but I'd like to hear any feedback here is, so our working group activities we've generated numerous recommendation and actionable items and a variety of potential paths forward. And we want to know what the best way to get this information to both decision makers and stakeholders. And so we've got this review paper, this workshop report. We're involved in a lot of these other efforts, but we want to know if there's anything else that we could do that will help our efforts, because we really like a legacy of this working group to really kind of have helped identify good paths forward, and then also help us along the way to achieving those goals. So anyway, thank you.
Thank you so much for that presentation. Does anybody have any thoughts to this discussion question? We have a couple of minutes to discuss. Feel free to unmute yourself and chime in.
So I'm Wilbert Dwyer. From a modeling perspective, we're very much used to the bulk formulations of air-sea transfer. From your working group, are there any fundamental challenges to that approach, or is it more a matter of improving resolution and the fundamental exchange processes are still properly represented by those rules, basically?
Yeah, that's a great question, and we have touched on this a bit in both the review paper and our workshop. We actually had quite a bit of discussion about what is needed more beyond bulk formulation. And one thing that kept emerging was number one is the need to incorporate surface currents observations into our bulk formulation. So most a lot of models and a lot of in situ estimates of air sea fluxes do not account for ocean currents. And there's some a few papers out there that have shown that if you do not do that, you will get different storm tracks and you'll get different air sea coupling, different eddy energetics in the ocean and things like that. So that's really important. The second one is the this emerging idea that as we go to smaller and smaller scales, the effects of wind wave current interactions become much more important. So the effect of waves on the fluxes, the effect of the feedback of waves onto currents and how that feedbacks onto the fluxes as well. So that right now is, and I think other people might have different perspectives on this, but I would say that that's really one of the critical parts going forward that we need to get a better handle on. And also the parameterization in models, incorporating these effects into models. Is there a good way to do it? That's still an open question, I think.
Great, thank you.
I see a question from Matt Newman.
Yes.
Yeah, hey, I had a question, I guess, more from the perspective of PPAI, and based on what I remember from the review paper. Do you think useful recommendations more in terms of the impact on climate predictability on, say, subseasonal to seasonal, annual to decadal timescales? The review paper was kind of light on the impact on large-scale atmospheric dynamics, and I do get a sense that the working group was much more focused on the ocean side than on the atmospheric response. And of course, there are questions about whether and to what extent variations in the western boundary currents might have in the atmosphere response downstream, not just locally over the oceanic front.
Yeah. Hyodae, do you
Yeah, so can you hear me okay?
Yeah.
Okay, so yeah, yeah, Matt, you're right. I think the review paper is much more onto ocean response, and as well as some aspect of storm track response. So it's like synoptic time scale to maybe sort of a little bit of subseasonal variability, but not onto much larger scale and longer time scale variability. And that reflects the, I think the state of our understanding. I think there are not many papers that are looking at the large scale, low frequency variability impact by this western boundary current variability, compared to a lot more studies that focus on ocean dynamical responses or instantaneous storm track response, things like that. So I guess I think review paper reflects the current sort of imbalance in understanding of different space-time scales and different medium. But as Larry elaborated quite nicely, I think that's really the open area for future research, is to look at the, whether if you resolve the western boundary current area interaction in the western part of the basin, do you systematically improve the predictability of precipitation over land, right? So I think there should be some systematic study, and what time scale and what does predictor from the western boundary current compare with predictors from tropics that are much better established, in my view. So I think there are a long way to go in that area, and I think that's one kind of, in my view, important area for future research for community, and that's, I think, should be reflected in our recommendation for the workshop. Yeah. Does that answer your question, Matt?
Yeah, I think that gets out.
Thank you. Yeah.
Okay, I see a few more questions, but it looks like it's 2:30, so I don't want to hold anybody over. But if you would like to email Larry or Hyodae your questions, I'm sure they'd be happy to answer. As a reminder, next week we will hear from the Climate and Health Working Group at the same time, so mark that on your calendars. And that's all we have for today, so have a great weekend, everyone.
Thanks, everyone.
Thank you.